Conclusion of the session, a feedback form will be posted in the chat box. Please fill it out to receive your e-certificates. Now, let's begin the session with a welcome note. Good evening to one and all present here. Thank you for your presence and for spending your precious time to attend the session, which is inviting you to give the knowledge which you wouldn't mind taking back to yourself. I welcome you all to the exciting Old Vista webinar event organized by IEEE Power Electronics Society Madras section in association with IEEE Power Electronics and Industrial Electronics Society Madhya Pradesh section, organized by St. Joseph College of Engineering, Pels. I'm Jasmine and my co-host Alex, and it's our privilege to guide you through this capitative journey into the vast expanse of knowledge. Let's start with our speaker's welcome note. We are delighted to welcome Professor Shravani Mathur, an esteemed educationalist and a researcher, to our online event today. With a background in electrical and electronics engineering and a wealth of experience in academia, Professor Mathur has made significant contributions in the field. From her early education at Army School, Gorakhpur, to her tenure at prestigious institutions like Sri Ram Marpur Memorial College of Engineering and Management, Lucknow, and Oriental Group of Institutions, Bhopal. Professor Mathur's journey reflects her dedication and commitment to excellence. Professor Mathur's influence extends beyond academia. She has been a keynote speaker at prestigious institutes like IITs and has been actively involved in leadership summits and conferences worldwide. Her involvement as a publicity brand ambassador for IEEE TNS/MP 2021 and her recent service as the publicity committee head for the IEEE WIE International Leadership Summit 2023 exemplify her leadership and organization skills. With around 20 published articles in national and international conferences and journals, Professor Mathur's research contributions have significantly enriched the academic discourse in her field. Without any further ado, let's warmly welcome Ms. Shravani Mathur. Now the session is entirely yours, ma'am. You can carry on your session.
Thanks so much, Jasmine. And thank you, St. Joseph College of Engineering, for inviting me for this prestigious lecture. Now I will share you my slides and we will begin the lecture. So the topic of today's talk is design of AC-DC hybrid microgrid using renewable energies. We all know what is renewable energy. Let us have a look at the contents of First, the introduction. What is hybrid microgrid, or what is the combination of AC and DC hybrid microgrid? I mean, what is actually a microgrid? We have to study in the introduction section. Then we have the microgrid explanation. What is there inside? What are the components, different components of microgrid? And then what is hybrid? It is the combination of, hybrid means combination of two things. This means this is the microgrid which is comprising both solar panels and wind turbines. So next topic is solar energy, how we can use or utilize the solar energy for the generation of electricity. Then wind energy, how we can use wind power to generate electricity. What are the methodologies involved and include? What will be the result? And then further conclusion from that result. So let us start with the introduction. Renewable energy is the energy obtained from sources that are essentially inexhaustible. Inexhaustible means which can't exhaust in coming thousands or lakhs or crores of years, like that of solar energy or wind energy. The most important feature of renewable energy is that it can be harnessed without the release of any harmful pollutant. Means your environment will remain safe if you use such kind of, energies for the generation of electricity in comparison to the conventional ones like coal or like further petroleum. So it is more beneficial for the environment as well. This works cover the realization of a hybrid solar wind energy system for domestic purposes. see, when we install a solar panel on the roof of our houses, the how the electricity can be generated, and it can be used by us in our homes at the at 240 volts 50 hertz. And this is the MATLAB Simulink representation of that particular um, what we are in real life, using in real life. The batteries are charged either by wind power. A small alternator is there. Small alternator is basically a AC generator which generates electricity. Means the rotor blades are combined to the rotor of the wind turbine. When the rotor rotates, blades also rotates, and then it is connected to an alternator through the shaft. Through the shaft, it is connected to the alternator which generates electricity. Or solar power can be controlled by MPPT module, that is maximum power point tracking module. So this is the two basic grids which we are using nowadays, but we will tell you about the combination of these two grids. Basic DC microgrid. The first figure is of basic DC microgrid, and the second one is of basic AC microgrid. Now, what is DC microgrid? You can see here, these are the two solar panels or PV arrays, right? PV1, PV2, panel 1, panel 2. These are providing you the DC output. These are providing you with the DC output, right?
Excuse me, ma'am. Ma'am, your presentation is in the first slide itself, ma'am.
It's in the first slide.
Yes, ma'am.
Can you share the presentation, Jasmine?
Yes, ma'am.
Yeah.
Wait a minute, ma'am.
Please share.
Is it visible now, ma'am?
Yeah, it's visible.
Okay. Which slide, ma'am?
Third slide, and put it into the full screen mode.
Okay, ma'am.
Fourth slide.
Okay, ma'am.
Have you done the full screen?
One minute, ma'am. There is a technical issue from our side. That's why.
Shall I share it once?
Ma'am, is it?
Yeah, shall I accept?
Okay, ma'am. Just share it one time because we can't able to share it in a full screen, ma'am.
Okay. Okay, there is no problem. I will continue with this kind of, this is basic
Okay,
DC
ma'am.
microgrid. Yeah, you can see these types of, now my fourth slide is visible to you all. Can you see the basic DC microgrid? Yeah. Then this is the PV array. This is the first solar panel. This is the second solar panel, and it outputs the DC voltage. Then this DC voltage is passed through a converter, which finally goes to a DC bus, And this is the wind power system. This is the wind turbine, which is producing AC power, alternating current power. But again, we have converters here, and we convert it to a DC. WT converter means wind turbine converter, and we are converting it to a DC output. And finally, this DC output is going to the DC bus itself, right? Then what's happening? We have load here. Load is also of AC nature load. That means our household loads and commercial loads. And in our household, we generally have the voltage at 240 volts, 50 hertz, right? And this is the battery storage. Battery storage is made up of lithium ions, and when we don't have sun and wind in the night time, then what happens? This battery gives the power back to the DC bus. Okay, this battery gets charged when the solar power is giving the energy and the wind power is giving energy to the DC bus. The battery is getting charged during the daytime. But when there are the periods when there is no wind and no sun, that is in night most probably, then what happens? This battery gives back to the DC bus, and finally it goes to the loads, right? Like this, from DC bus to load. So this is all the DC microgrid, and this is the basic AC microgrid. Now, what is AC microgrid? It starts from the grid, then there will be an intelligent transfer switch. It is connected through a circuit breaker, then it is connected to various inverters. Here we can apply voltage source inverters, VSIs, which I will explain you in my further slide, the components and its basic structure and what it does. Inverter, what does basically? Inverter converts DC into AC, and finally this AC is gone to our household or commercial purposes. So this is the next slide. What is exactly microgrid? Group of interconnected loads and distributed energy resources, DER, with defined electrical boundaries that acts as a single controllable entity is called microgrid. This is the prime mover, DC interface, inverter, then finally inverter. After inverter, we get the AC output from the prime mover. Is what? Prime mover, it can be a wind turbine, WT, or it can be a solar panel. And then this DC is gone through the inverter, then it converts into AC and goes to the load. Hybrid system. Hybrid power systems may contain controlled and uncontrolled energy sources and energy storage elements with appropriate control systems. means that they contain both the types of elements, controlled and uncontrolled. Like some of the characteristics are not linear, some characteristics are non-linear in their components in the hybrid system. And then we come to the need of hybridization. Why we need to hybridize our system? See, what is a national grid? Grid is comprised of three basic components, that is, generating station, then transmission system, transmission lines and transmission towers, and then you can say distribution system. Now, what is happening? Instead of generating through coal, conventional resources, we are generating by inexhaustible resources, which are pollutant free and inexhaustible. They will remain with us for thousands, lakhs of years. Okay, so what is the need of hybridization? For increasing output, means if we have solar energy in the daytime and wind energy which is flowing, and we harness that energy, and if we put this energy into a battery energy storage system, then what happens when there is a night time? Then what happens? We don't have solar energy. So the battery will give you the energy at that time. It will give you the energy to the load, to the commercial load, to the domestic load. So these are the various factors for the hybridization. Providing uninterrupted power supply. What I have said earlier, that if we use solar and wind energy in the daytime or when there is a lot of wind, but if there is no wind, then we can harness the energy of battery storage system, which is made up of lithium ion generally. Then comes the solar energy source. You can see in the figure what happens. You can see the solar panels installed somewhere. These are installed for harnessing the solar energy. Now, sun is providing the energy. This is the irradiance which is captured by the solar panels. Then there is a charge controller which controls the excessive generation of the electrical energy. This controls the excessive generation of the solar energy. Then this gives the energy to the battery system because it is the DC power, right? DC power, it is gone to the battery system. It will store the energy and it will provide the energy when there is no sun. Okay, when there is no solar energy, then it will provide the inverter. Inverter, what does inverter do? Inverter converts the DC power to the AC power, and finally it goes to the AC loads. What is AC load? We are the AC loads, means domestic and commercial both. And this AC is supplied at which voltage? 240 volts, 50 hertz. So this is the whole process which is taking place. You can see it clearly. I will tell you, commercial residential PV modules range in power output from 10 watts to 300 watts. In a direct current, a PV module must have an inverter to change the DC electricity into alternating current energy in order to be used by electrical devices and compatible with the electrical grid. Now come to the equation which is taking place. The solar cells exhibit non-linear current voltage characteristics as shown below that depend on solar radiation and temperature. Now, what is I? I is the current produced by the solar panels. So, I is equal to IPH minus I naught e to power V plus I RS upon NKT minus 1 minus V plus I RS upon RSH. Now, what all these represents, I will tell you. IPH is the photocurrent. It is the photocurrent produced by the solar panels. I naught is the saturation current of the diode. Saturation current of the diode. RS is the series resistance. RSH is the shunt resistance. And N is the diode ideality factor. N is the diode ideality factor. K is the Boltzmann constant, which is equal to 1.4 into 10 to power minus 23. Q is the electron charge, that is equal to 1.6 into 10 to power minus 19. T is the absolute temperature in the Kelvin. So this is the equation for the current, which has the non-linear relationship between the current and voltage. The solar cells. Now, this is the structure of the PV system. Structure of the PV system, you can see this is the solar panel. It is getting energy from the irradiance. Irradiance means the radiations from the solar sun. Then the ambient temperature. Ambient temperature means the temperature of that particular time. Then boost converter is connected. What does boost connector do? I will show you the diagram in my coming slides of the boost converter. And it is then this DC output is fed to the inverter, which is controlled by the Droop control system. Droop, D-R-O-O-P, Droop control system. And MPPT system is connected with the boost converter. MPPT represents what? Maximum power point tracking system. Okay, then this inverter converts DC into AC and it finally gives to the microgrid bus. Is it clear up to here? What is basically solar energy, how solar energy is converting into electricity? Or shall I tell once again? Okay. What is ESS? ESS is basically energy storage system, or you can say this is a battery. Okay. This is the battery and it stores the DC output. Okay. DC power. It stores the DC output, which we get from the solar panels. Now come to the wind energy. What wind energy? You can see here a line of wind turbines are installed where the wind power can be harnessed. Especially at the mountains, we get a lot of wind power, and this is the basic structure. This is the rotor inside here. Rotor inside here. These are the blades of the wind turbine, and it rotates. And what is pitch? See, this revolves around the rotor. Blades revolves around the rotor, and they also rotate along their axis. Okay. So I will show you in my next slide how this happens. Wind turbines operate on a simple principle. The energy in the wind turns in 2 or 3 propeller-like blades around the rotor. These propeller-like blades are around the rotor. The rotor is connected to the main shaft. It is connected to a shaft which spins a generator to create electricity, which spins, this shaft spins, and it is connected to an alternator, or you can say AC generator, which generates finally the electricity. So wind energy is a free, renewable, and clean resource of the energy. Wind turbines are mounted on a tower to capture the most energy. These are mounted upon the tower. They are not at the base of the tower. They are at the top of the tower to harness maximum energy. Okay, now come to the next slide in which I will tell you how this looks like. I am explaining you this portion of the wind turbine. This is the portion. You can see here, we can start from 1. One is the blades. These are the blades of the wind turbine. Second is the rotor, which rotates 360 degrees. And these blades rotates along its axis also. This is called third. You can say third one is called the pitch. This rotates along the pitch also. Means these blades are rotating also and revolving also. Okay. Then what happens? Fourth is the brake. Fifth is the, then there is a gearbox. This shaft is connected to a, finally, what is the 7th? Generator. And generator is, finally, generates the electricity and it gives. Now come to the next slide. The wind turbine gets the torque from the pressure of the wind. From where the wind turbine is getting the torque, it gets the torque from the pressure of the winds, the pressure exerted by the winds on its blade. Blades rotates along its axis and also revolves around the rotor. Okay. And the mechanical torque is converted into electrical power through a generator. The single mass shaft is based on the equation below. T tau minus TB is equal to 2H dW upon dt. Problem identification. Now, how we can connect both of these and solar energy to solve our electricity problem. It affects end users, equipment and system manufacturers, designers of plant, installations, electricity distributors, and public. Overheating of various machines in the power system. Overheating of various machines like transformers, motors, etc., leading to reduced useful life. The economic impact of power quality issues can be divided into the following categories. It creates the power quality issues also. So, partial or total loss of one or more processes, that is loss of process control due to voltage sags and swell. Reduced long-term productivity and quality. Under voltages, over voltages, interruptions, DC offsets, notching, and various other things. Now come to this slide. What is this? This is the structure of buck-boost bidirectional converter. This is the buck-boost bidirectional converter. You can see here, this is R1L. These S1, S2 represents the MOSFETs. There are the two MOSFETs. Then D1 and D2 represents the two diodes. C1 and C2 represents the two capacitors, which is C1 is the low voltage side capacitance and C2 is the high voltage side capacitance. When S1 is switching, S2 is off and S2 is off. So it is in the boost converter stage. The battery discharges the energy to the microgrid. Means the battery discharges the energy to the microgrid. That means it is providing the energy to the microgrid. And when vice versa is happening, means S2 is switching and S1 is off, the whole system is the buck converter and battery is getting charged. And in this stage, battery is getting charged. Now, you can see the circuit of voltage source converter. You can easily see that there are 6 switches, S1, S2, S3, S4, S5, S6, 6 switches which are connected to 6 diodes. And this UDC, what is this UDC? UDC is the direct output voltage from the solar panel. The solar panel is producing the direct output voltage, DC voltage, okay, DC power. So UDC is the direct output voltage from the solar panel. CDC is the filter capacitance, LF is the filter inductor, and RF is the filter resistance. Now, UA, UB, UC represents the output voltages of the inverter. These represents the output voltages of the inverter, and IA, IB, IC represents the output currents of the inverter. This is a VSI, circuit of voltage source converter, VSI, which is taking the DC power and it is converting through the combination of diodes, and it is converting the DC power into AC power, AC currents and AC voltages, and finally these are getting into the power grid. Okay, power grid. Methodology. What methodology we install, we apply when we go for a AC-DC hybrid microgrid. It comprises, we all know that it comprises of both wind turbine, which has doubly fed induction generators. What kind of generators are installed in the wind turbine? These generators are doubly fed induction generators. Okay, means DFIG. A photovoltaic generator, PV modules are there, photovoltaic arrays are there. a proton exchange membrane, PEM, fuel cells, FC, a generator, a water electrolyzer, hydrogen tank, and a battery bank. We have all seen in the diagrams, and we have explained that the system configuration and the characteristics of main components in the proposed system are given, and overall control and power management strategy for the latter is presented. In addition, the dynamic models of boost DC-DC converter, I have just explained you right now. In my previous slide, I have explained the boost DC-DC converter, and a bidirectional DC-DC buck boost converter is considered. I have shown you this is that slide in which this is a bidirectional buck boost converter. Bidirectional means the battery gives the power to the grid also, and battery gets charged when it is in the buck converter form. Buck converter form means when it happens when the switching S2 is switching and S1 is off, then it is in the buck converter state. Okay, so a battery bank is used for short-term energy storage and an electrolyzer is used for long-term energy storage. Battery bank is short-term energy storage, means when we store the energy the whole day, solar panels generate the electricity and give it to the battery. Then in the night, when energy is utilized by grid or AC load, then it gives out the energy to the AC loads. The excess power from WT, DFIGs and PV generator is then used for charging BB and for the water electrolyzer to produce hydrogen. Okay. The FC and the BB work as the backup generator. FC means fuel cell, and battery bank work as the backup generator to supply the demand required power when WT, wind turbine, DFIG and the PV energy are deficient. When these are deficient, then what works? In case when these two are absent, then what happens? The fuel cell and the battery bank will give the desired power, required power. Overall system is designed using MATLAB Simulink. Now come to this system component and block diagram. System component, these are this is the wind turbine. These are the solar panels. These are charge wind controller, PV charge controller. Why these controllers are installed here? These controllers are installed here to limit the excess of power generation through solar panels and through wind turbine. It limits the excess of power generation through these two, and then finally these powers are gone into the battery bank and DC-DC inverter. Finally, it goes to the load. Goes to the load. Battery bank is also a DC output. This will give you a DC output. Then this DC is fed into this inverter, which I have shown you earlier in the earlier slide. Then this inverter gives you the AC output, which is given to the load. And what are the function of this wind controller and charge controller? They limit the excess of the power which is generated by the PV arrays and wind turbines. So these are the points written over here, and I have explained you this diagram. Now more better diagram, that means establishment of a wind PV hybrid unit. You can see here wind turbine generator. Okay, wind turbine generator, when this rotates like this, okay, blades rotate, revolves around the rotor, and they also rotates along their pitch, axis of their pitch. This is the photovoltaic panel. Now this is producing DC power. But this is producing AC power. Wind turbine is producing the AC power. Solar panels are producing the DC power. Okay, now this DC power goes to the battery as storage, and then DC is converted into AC by the use of inverter. Then this inverter, there is a AC filter, means proper AC goes to the load. And what happens when both these are not, then battery will give you the DC power, and then DC is converted into AC. It passes to the AC filter, and finally it goes to the load. So this is all about the AC-DC hybrid microgrid. Now, photovoltaic modules. Photovoltaic modules can be wired together to form a PV array, photovoltaic array. Modules are combined to form a PV array. That is, by wiring modules in series, the available voltage is increased. If you need increased voltage, then wire the modules in series. And if you need increased current, then wire the PV modules into parallel. Okay, a typical PV module measures about 0.5 square meters, about 1.5 into 3.5 feet, and produces about 75 watts of DC electricity in full sun. So if a tile of a solar panel, which is of 1.5 feet length and 3.5 feet breadth, it produces about 75 watts of DC electricity if there is full sun. DC AC inverters. DC AC inverter changes low voltage direct current power, which is produced by the PV or wind turbine or stored in the battery, into standard alternating current house power, that is 120 or 240 volts at 50 hertz. The modern sine wave inverters supply uninterrupted power. There are no blackouts. Inverter comes in the size of 250 watts to over 8,000 watts. Safety equipments. Now, if there are over voltage or over currents, if present in the system, then what happens? We have to transmission system or generation system. So we have lightning arresters also to protect the system. Now, meters and instrumentations required. It helps in keeping track of important things like battery voltage. How much is the battery voltage? A battery has a SOC. SOC means state of charge. How much it is charged or how much it is discharged. Means it depends upon the loads. It depends upon the load, how much part of battery is charged and how much is utilized, means discharged. The amount of power they are currently consuming. The state of charge in their batteries. What is the state of charge? Okay, now come to the next slide. That is, now this PV system to national voltage grid is connected through a transformer. My PV system, that means solar panels, are connected to the national voltage grid, through the transformers. As you can see here, this is the primary winding connected to a voltage source. That means voltage produced by the solar panels. Then this transformers, this is the secondary winding, and it is connected to the load. That means it is connected to the national grid. This is the basic diagram of the transformer installed in our AC-DC hybrid microgrid. what is the purpose of the transformer? Either it steps up or steps down, but here we are taking the step up transformer because at the primary side, the output of the solar panel is very low and it is in the form of DC. So before that, we have an inverter to convert the DC voltage of solar panel to AC, and then this AC is fed to the transformer's primary winding. And because of the mutual inductance of the transformer, or electromagnetic induction is there. The current also flows in the secondary winding. And this current goes to the national grid. Now, batteries. Batteries store electrical energy produced by RE source in reversible chemical reaction. Most batteries employ lead acid batteries. Typically, lead acid batteries are there, encased in a plastic and wired together in series and parallel strings by the installer. Batteries are either connected in series or in parallel, and they are encased in a plastic case. A typical 12-volt system may have 800 ampere hours of battery capacity. So this is the 12-volt system may have 800 ampere hours of battery capacity. Okay. Now come to the charge controller regulator. Where we have installed this? We have installed this at I have shown you now. So it prevents the PV array and wind turbine from overcharging the battery. Most modern controllers maintain system voltage regulation electronically by varying the width of DC pulses they send to the batteries. This is called the pulse width modulation, or PWM. Most modern controllers maintain system voltage regulation electronically, means by varying the width of DC pulses. Have you heard about the pulse width modulation? What is that? A carrier wave is compared with the sinusoidal wave, sawtooth wave, and the output we get is in the form of variation of the width. So it is called pulse width modulation. It is called the pulse width modulation. Another category called shunt type controllers divert excess energy into a shunt load. So the aerodynamic power at the rotor of turbine is given by aerodynamic power of the wind turbine is given by PM is equal to, that is, mechanical power of the wind is converted into the rotational motion. I mean, mechanical power means the rotational motion of the wind blades, and it's equal to half rho pi r square V cube Cp lambda theta. Now, what is this? The power of the wind turbine is in proportion to the air density rho. The area of the turbine blade, that is pi r square, the wind speed V, and the power coefficient of blade Cp. The air density in this case is taken as 1.225 kilogram per meter cube, and radius of the blade is 39.26 meter. The power coefficient is also related to the tip speed ratio, TSR, tip speed ratio. This is the structure of which controller? Omega reference and omega. Omega reference is taken and these both are compared, and the error is fed to the PI controller. Then pitch angle saturation is done and rate limiter. So this is the structure of a pitch controller. Now come to the basic MATLAB diagram, which we have designed in the simulation in Simulink. So this is the hybrid PV, WT and FC. Hybrid PV means photovoltaic, WT means wind turbine, FC means fuel cell. These three are taken into consideration. Then it passes to the transformer. it passes to the transformer. Then it goes to it gives you the VABC, IABC. Then battery bank is there, B1 and B2 battery bank is there. See, the voltage or power generated by this is in the form of either DC. So inverter is there to convert the DC output into AC. Then AC is fed to the primary side of the transformer, and in the secondary side, due to the electromagnetic induction, a current starts flowing. These are three-phase currents and voltages of which goes to the battery bank also, This is the DC bus, and then it goes to the national grid also. This is the three-phase source, or you can say it gives it, this is the national grid. Now come to this photovoltaic WT means wind turbine and fuel cell to DC-DC bus and DC-AC bus. What's happening? If you can see this diagram, a fuel cell is here. DC bus, and then it goes to the national grid also. This is the three-phase source, or you can say it gives it, this is the national grid. Now come to this photovoltaic WT means wind turbine and fuel cell to DC-DC bus and DC-AC bus. What's happening? If you can see this diagram, a fuel cell is here, inverter is here, wind turbine. I will show you in my next slide what is happening inside the wind turbine. Okay, so this is the wind turbine, this is PV array, and this is fuel cell. Actually, this slide is I have shown you this component of the main slide. I am showing you in my next slide the enlarged diagram of this in my next slide. Means the combination of WT, PV and FC. WT means wind turbine, PV means PV array, and fuel cell is FC means fuel cell. Then what happens in PV array? We give the irradiance. Irradiance means the power of the sun. And temperature. It is fed to the PV solar cell. Then it passes through a buck boost converter. It passes through the buck boost converter, and finally the output is here. In wind turbine also, it passes through a buck boost converter, and this is the scope at which we can see the various waveforms like voltage and current waveforms, and this is the fuel cell. Now, in my next slide, I will show you this calculation of photocurrent in PV module. I have given you the equation of the photocurrent in PV module, and this is the MATLAB Simulink of the. Now come to the WT with converters, wind turbine with converters. You can see the turbine and drivetrain and wind turbine. These are the various control systems, various VABC, and you can see in the MATLAB when you run this, what happens. See, this is the DFIG. DFIG means doubly fed induction generator. Okay, it is the induction generator machine, and this is the universal bridge, and this is the inverter, and finally it is going to the national grid. Finally, it is giving the output, electrical output to the AC power to the grid. Okay, so this is the working. I have already explained you. Now these are the results. This is the typical PV module unit, current, voltage and power voltage characteristics showing the effects of irradiance in power module. Means solar panels, it is the graph between the power, voltage and current. You can see it here. Now what does it implies? I'll tell you. Results, DC-DC microgrid voltage. This is the microgrid voltage. It is the DC because it's DC. It's generating from the solar panels and again SOC, current and voltage of the battery. Battery is also a DC battery. So SOC is the state of charge, where how much it is charged or how much it has discharged, okay, to the national grid, and current waveform and voltage waveform. Actually, all these are DC waveforms, so they are constant. They are constant after a time period. Now, these are the characteristics of FC, means fuel cell. Voltage and current of AC, DC-AC converter, DC-AC converter. These are the three-phase voltages and currents. Voltage, three-phase, because I have shown by the three colors of three-phase of voltages and three-phase currents of DC-AC converter, which I have shown in my earlier slide. And you can see voltage and current of the load. Voltage and current of the load, load is 240 volts, 50 hertz. It can also be shown by the three different colors, the voltage for voltage and current both. So this is the outcomes. The performance has been improved. The establishing techniques for accurately predicting their output, and we get energy from inexhaustible and non-pollutant resources for a locally distributed system. So thank you all for all this. And if you have any questions, you can ask me. See, we have, somebody has asked, Mr. Jason Alexander, sir, he has asked, what is the trade-offs between the pulse width modulation, PWM, and other modulation methods in VSC? Okay, so first of all, the pulse width modulation is between, you can see, yeah, a carrier waveform is compared. A carrier alternating waveform is compared with the sawtooth waveform. This is the pulse width modulation technique. And if we talk about sinusoidal pulse width modulation, there is not a big difference between that, because we get the modulated waveform. But what happens? We use pulse width modulation in VSCs. Because pulse width modulation, there is no much difference. We have the categories of sinusoidal pulse width modulation. We have, okay, so there is not a big difference, but we are using pulse width modulation in VSI or voltage source inverters. Next question is, what regulatory challenges and opportunities exist for the deployment of battery storage system. See, battery storage system, battery does not store the almost, it is not charged to the 100%, right? One challenge I can say that it is not to charge to the 100% SOC, okay, state of charge. We have its charge at 85 to 90% state of charge. And when it starts discharging, what happens? It discharges from 5%, and so these are the challenges which we have to overcome by designing various better quality of batteries, because the whole optimized utilization of battery is not being done yet. Next question: what are the common failure modes in VSCs and how can they be mitigated? Common failure modes. Common failure modes is see, when we have less power supply, or if we have a blackout, then we can say it can be the failure modes of VSC, or otherwise it provides what we are expecting from that. Means it is also efficient, but if blackout happens, then it doesn't work. So it does not have any kind of it does not have any kind of limitation. It is quite okay. Only in the case of blackout, or only in the case when there is some fault in the network, then this happens. Any other question?
Yes, ma'am. I hope that's the end of the query session, ma'am. Thank you for answering those questions, ma'am. It was really an informative session for us. So next, now I would like to call Jasmine to distribute a guest of appreciation to our resource person for the day. For the resource for the day. Mr. Vanimatu. Ma'am, is it visible, ma'am? Wait a second, ma'am. There's an internet issue.
Thank you so much. Thank you so much, Jasmine and the team, and basically St. Joseph College of Engineering for inviting me. And I hope you get something from today's lecture. And if you have further queries, you can contact me on Shravani Mathur at IEEE.org.
Ma'am, with your permission, can we have a group lecture?
Yeah, sure.
So, okay. I request all the participants to turn on the camera. On the count of 3, 2, 1, I will take the click mark. 3, 2, 1. Thank you, ma'am, for capturing your moment. So this is a session to close. Let's proceed with the vote of thanks, ma'am. On behalf of our esteemed audience and the organizing committee, I extend heartfelt gratitude for gracing our event with your profound presence. Your wealth of knowledge and dedication to the field of the power electronics left together. Your commitment to try bridging the between academia and the industry is truly commendable. Your vision for a sustainable and interconnected world inspired us to the horizons in technology. Thank you, Ms. Shravani Mathur, ma'am, for being a knowledge and guiding on the enlightening journey. And we are honored to have you with us, ma'am. Thank you, ma'am.
You're welcome.
Let's end this participants' feedback. This feedback makes our forthcoming sessions more valuable. Feedback link will be posted in the chat box. Participants will be requested to fill out the feedback form before leaving the session to receive your e-certificates. Thank you all. Participants are kindly requested to fill out the feedback before leaving the session to receive your e-certificates. Thank you. Thank you so much, ma'am.